Hello everyone, in this video we are going to see all about the Snowflake architecture in detail. Before we get into the Snowflake architecture, let's see the traditional architectures. First, let's see the shared disk architecture. In shared disk architecture, all nodes in the cluster access a single centralized storage system. Each node has its own CPU and memory but shares the same storage system. Some of the examples of shared disk architecture are SQL Server, MySQL, and Oracle. Some of the key features of shared disk architecture are all nodes read and write to the same storage. If one node fails, still the other node can access the data. The main disadvantage of the shared disk architecture is if there are simultaneous writes to the disk, there could be concurrency challenges. The next traditional architecture is shared nothing architecture. In shared nothing architecture, each node operates independently with its own CPU, memory, and storage. The data is partitioned shared across the nodes and queries are routed to the related nodes. One of the examples of shared nothing architecture is Apache Cassandra database. Some of the key features of the shared nothing architecture are there is no shared resources, each node manages its own datasets. So in shared nothing architecture, it is easy to scale. It is easy to add or remove nodes and database depending on our demand. But the main disadvantage of shared nothing architecture is cross-node joins or transaction requires distributed coordinations. Snowflake combines the best of both the architectures. Snowflake uses shared data layer which is similar to the shared disk architecture. In Snowflake, we also have multi-cluster compute layer which is similar to the shared nothing architecture. If you see in this diagram, we have a centralized storage system, but we also have three different clusters of different size in order to access the shared data. Some of the key features of Snowflake hybrid architecture is all compute nodes access the same centralized storage. At the same time, compute resources are decoupled from storage. This allows independent scaling of compute and storage. The compute clusters can be increased or decreased dynamically depending on the workload demands. Now let's see how Snowflake works. In Snowflake, there are three main layers: storage layer, compute layer, and cloud services layer. In Snowflake, data is stored in the storage layer, which is in the cloud-based storage system. The next layer is the compute layer. In compute layer, there are virtual warehouses to process the queries. Virtual warehouses are nothing but clusters of compute nodes. Each virtual warehouse can operate independently and can access the centralized storage system. The next layer is the cloud services layer. The cloud services layer manages query optimization, transaction management, and access control management. Snowflake is fully managed and cloud native. That means that Snowflake entirely runs on cloud platforms like AWS, Azure, and GCP. Snowflake uses unique cloud-native hybrid architecture known as multi-cluster shared data architecture. First, let's see the centralized storage layer. When data comes inside Snowflake environment, Snowflake reorganizes the data into optimized, compressed, and columnar format. In Snowflake, data is stored in micropartitions. Micropartitions are Snowflake's proprietary method of storing the data in columnar format. The data objects created by Snowflake are not directly visible or accessible by the users. The user can access the data only by running queries from Snowflake. The storage is centralized and fully managed by Snowflake. The next layer is the query processing layer. The query processing layer is the middle layer of Snowflake architecture. The query execution is performed in the query processing layer via virtual warehouse. Every virtual warehouse is a massively parallel processing compute cluster that contains one or more compute nodes that are allowed by Snowflake via the cloud provider. It is responsible for actively executing SQL queries using powerful scalable compute cluster called virtual warehouse. The queries are broken down into tasks and processed in parallel across nodes. Virtual warehouses are independent compute resources that do not share their compute or local storage with other warehouses. Because of this, multiple warehouses do not interfere with each other, and virtual warehouses do not cause any performance bottlenecks. The next layer is Cloud Services Layer. The Cloud Services Layer is a collection of services that performs various activities across Snowflake. The Cloud Services Layer is the brain of Snowflake that manages the metadata, authentication, optimization, and many more. The Cloud Services Layer runs on compute instances provided by Snowflake from the cloud provider. Some of the key services of Cloud Services Layer includes authentication, infrastructure management, metadata management, query parsing and optimization, and access control management. As part of the access control in Cloud Services Layer, Snowflake manages user login, role-based access, and multi-factor authentication. It enforces security policies and data access privileges. As part of the metadata management in Cloud Services Layer, Snowflake manages metadata like table structure, statistics, and query history. As part of the query processing and optimization, Snowflake parses the SQL, generate execution plan, and optimizes query before execution. Snowflake handle cost-based optimization to improve performance. As part of infrastructure management, Snowflake monitors and orchestrates virtual warehouses. Snowflake supports features like data encryption, audit logging, masking policies, and row-level security. I hope you got a fair idea of Snowflake architecture, and I'm sure that you learned something new today. If you do like this video, please consider to subscribe, and I will see you in yet another interesting video. Thank you.